Hi, and welcome to this recording for Unit 39. Unit 39 deals with the moon. Remember, we're not really going to go through every single object in the solar system. We're just picking stuff that we can build on and then compare with other things. So far we did basically the Earth. Now the next object that we have our hands on and is closest to Earth is the moon. And that's because man has landed on the moon in the past, so we have actually a good idea of what the moon looked like in terms of structure, in terms of surface features, because it's not too far also that we can see with the telescopes and things like that, okay, even with the naked eye. Anyway, so basically here we're going to try to explain how the moon formed, okay, and also describe the main features of the moon. There are three main features, so that you know. There are what looks like seas, mareas. There are also craters, so those are left over from the impact that the moon has received. And then there are the highlands, the rest of the basically surface of the moon. Those are the main features. There are other features down the road. Then explain how craters and mareas form, and the fact that the moon also has no atmosphere. Okay, and then describe the orbit of the moon as it goes around itself and also around the Earth. Okay, so basically how the moon formed. There are some basic assumptions, so basically some several theories, and each and every one of them has kind of issues with it. Even the one that is accepted, it's still kind of I mean, it's the most likely. So let's talk about the ones that we have, okay? So one of them, in any theory that you have, must explain the fact that the moon recedes from the Earth around every year around 3.9 centimeters, basically almost an inch, slightly more than an inch, actually almost 2 inches a year, okay? So, one of the theories that we have out there is that the moon must have been captured by, it was a planet on its own, and then it was captured by the Earth. Remember, a planet is supposed to orbit the sun, and the moon is not orbiting the sun, so it formed near the Earth. So it must have been captured by the Earth, and instead of going around the sun, it started going around the Earth and then going around the sun with the Earth. However, this is not good theory because of the fact that the moon is too similar to Earth for this to happen. If it was a different planet, and we went there and we looked at the composition of the moon, we have seen so many similarities between Earth composition and the moon composition that this does not work because they are too different. Okay, I mean too similar in a sense that they must have contacted one another at some point in the past. So how about the twin theory, that they must have formed from the same cloud, same material basically that formed them? Therefore, and then when they formed where they are right now, and it happened that the moon was too close from the Earth to orbit it. Well, that also is not really acceptable theory, because actually the moon has also different material than the Earth does. So again, so it must have also at some point was not with the Earth. Okay, so it was not in the same materials, every single aspect of it. Okay, how about the expulsion theory? Basically, that it was part of the Earth, and somehow the Earth was spinning probably too fast and ejected it, and now later on it coalesced into a moon. Well, that's also not acceptable because of the fact that it has some differences in composition. So if that's the case, then they should be exactly similar. So the leading theory that we have right now is the giant impact theory, and collision between the Earth and a Mars-sized object, basically the size of Mars. It must hit the Earth just at the right angle to give it several things: the tilt, the current rotation, and all of the properties that the Earth has. So the way it must work is, this is based on numerical simulations. It must come at least, I mean, it must have a speed to give it the correct data, okay, to match the composition, the rotation, and the orbit, and all of that, and the orientation of the Earth and everything else. So you must have these numbers. It must be coming at a high angle, almost to the North Pole, and then coming with a speed of around 9 kilometers per second. Immediately after impact, the two objects started to spin together for a brief moment, and then, because it's really almost, it did not completely go into Earth. Okay, maybe this is what happened to Venus too, but Venus was an impact that was directly against the rotation of Venus and went completely inside. That's why Venus does not have a moon probably. So in this case, part of the moon stayed out, cleared the collision, and part of the Earth also came with it. So now you have the similarity in composition and at the same time the difference also in composition. So similar enough and not too similar because you have part of the Earth also going with it and part of the moon also going there. So again, now you have this mixture that is coming out of the two, and the Earth starts to heat up from the north down. The entire Earth basically became so hot from the collision. It's tremendous speed, by the way, 9 kilometers per second. That's tremendous kinetic energy because this mass is a huge mass. It's the mass of Jupiter, mass of Mars. So now the debris that was left over basically was in a ring format at some point and started to coalesce together. A lot of the debris fell back on the Earth. A lot of the debris fell back on the moon and then started to coalesce and then started to rotate. After that, the moon, because trying to adjust its rotation with the Earth, starts to drift away from the Earth. So everything can be explained with this theory, whether the composition, the rotation, the drift, and everything else. Okay, so this is the leading theory, as I said in here, and there are some critics to it, but this is the best we have so far. Okay, how the moon formed. In terms of its surface, I already mentioned the fact that it has mainly this what looks like seas. That's what Galileo thought that initially, that they maybe look like it's water, but it's not. It's actually lava. I mean, at least left over from after the lava basically cooled, it became kind of reflective and shiny with a smoother surface than the rest of the moon. And the word Marias again is coming from the Latin, which means seas. Okay. And then you have these craters. You have the biggest one is actually in the southern part of the moon called the Tycho crater, and after the Tycho Brahe, and it's a big one that you should really be able to see, especially during the full moon where the nights are clear. You could see that crater with the naked eye, and you see more of them actually, more craters. There are all kinds of them, and then there are these lines in here, these rails or rays that come emanate from this. Craters, and that's the materials that is ejected from the impact that formed these craters, again form this stream around these lines in here. So these are the main features. In addition to that, you have the highlands, which are actually full of also the rest of the bright region in here, the lighter gray regions. These are actually also they're full of impacts, so although granted that these impacts are like slightly smaller. Okay. So if you zoom in on the surface again and you see these craters, so it seems like this is, and we're going to come back to the Marias again, but the point being in here is that this is heavily cratered. The rest of I'm not talking about the Marias, talking about the highlands, for example, or even the craters themselves. They have a lot of these impacts that seem to be having like a kind of a circular shape, more or less. And some of them are small, some of them are big, and they're on top of one another. It seems like, so that gives us an idea of how to date this event. Obviously, the ones that are sitting on the top must have happened more recent than the ones on the bottom. Okay. Again, the lunar highlands are also heavily cratered, but not with the bigger craters like the ones that I was talking about, the first one, and they're actually mainly low density rocks because they're actually kind of from the leftover, of course, from the impact. When you have an impact of breaks and then it spreads around the surface of the moon. The Marias, as I was saying earlier, they are mainly the leftover from the flow of the lava in the past. So they have a big crater that hits the moon, then the magma that is sitting immediately underneath comes out and starts to flow. These areas are actually not clear or clean also. They are actually impacted by also some small craters, which means that because they're actually, for the main part, they're clear, that means that they must have happened after the early stage where the moon was heavily bombarded left and right. So this must have happened later, although there are some small craters on top of them, indicating that those happened after these events created the Marias. The structure of the Maria looks like it's a circular shape. Sometimes, especially with the big ones, you have a kind of peak in the middle. And if you can do this experiment, actually, you can go on the surface of a calm lake and drop a rock. I mean, you don't have to be on a calm lake, a kind of big, basically a swimming pool. You can do that too. You can drop a rock, and you will see those circular shapes that start to form around it. Okay, you can take with a fast camera. You can take an image, and you will see those rings that form around the lake. So this is what must have happened. These are tremendously moving fast particles that hit the surface of the moon, and they form that. And you can actually repeat the experiment on actually sand. You don't have to do it on water. Okay. If you have had a chance to go to a meteor crater in northern Arizona, where there is a big impact on the surface of the Earth, well, it's a good chance to look at it and see exactly how those layers are formed and how the inside comes out. Basically, the different layers of the Earth are flipped upside down when it comes to the surface, the edge in here. In addition to that, you have these rails, these lines in here that seem to stretch. It looks like it's rivers on the surface of the moon, but they are not. They are actually the flow again of the lava during that stage, and they left this kind of a marks on the surface of the moon. Well, because we will see that the rotation of the moon is synchronized in terms of its rotation around its own axis around the Earth. So we only see one side of the moon. This is the near side. This is the other side, the far side of the moon, put side by side. Okay. Both of them are similar, more or less, except that the frontier has more lowlands, more Marias than on the other side. Although this Maria in here is actually Aiken Maria. Maria is a very, very deep one, and actually that's actually the subject of the Chinese mission in 2019. Okay, so they landed in there to study the surface of the moon. So again, the fact that we call it the far side doesn't mean that it doesn't receive sun. It does, and it's also impacted as much as the Earth, except that probably, again, because of the synchronization, most of the debris was falling on one side from the Earth than the other side. Okay, so that's probably what happened to the surface of the moon. In our missions in the 1970s, scientists or astronomers left seismometers in there to measure the moon quakes. And based on that, we have an understanding of how the surface of the moon is. On the side that is closer to the Earth, the crust is kind of a thin crust, about 65 kilometers, versus that of the far side, which is about more than double, actually, almost 150 kilometers thick. So it's super thick. And the mantle is there, but there is not enough heat in it to cause convection and basically tectonics motion. So there is heat, but it's because the moon is smaller to begin with than the Earth. So it must have lost most of its heat, and hence basically a lot sooner. And the object, the bigger it is, the more it retains in heat than a small object like the case of the moon in this case. The core in this case seems to be a little bit not in the center, but again, it's a very small core, and it must be hot. So that's again based on the current understanding of how the moon is structured. Okay. The way Marias form, basically, when you have an impact, a big impact, a large body coming at a big speed in here, it's going to eject materials and form this ridges, these mountains on the ridges, and then the area that is closer to the magma allows the magma to flow on the surface, and that's probably how this region is formed in here. Okay. In terms of atmosphere, the moon does not have much atmosphere at all. As a matter of fact, this picture is taken from the astronauts, and it's still in there because there is no atmosphere, there is no weathering. And like the Earth, for example, Earth also must have been subject to the same bombardment that the moon was subjected to. And so that gives us an indication. So the fact that we're looking at the moon gives us an indication what happened to the solar system immediately after it's formed. A lot of the debris and leftover material must have came back and fallen on those newly formed objects, and but you don't see much of them on Earth. I mentioned the meteor crater in northern Arizona, but you can find more than that on Earth, but not as much as you do on the moon. And that indicates that the Earth because because the Earth has an atmosphere, has water cycle, has all kinds of uh, phenomena that resurface, change the surface on a regular basis. Convection also, that's another process of changing the surface of the Earth. So unlike the Earth, the Moon does not have an atmosphere. It has some traces of hydrogen, and that's probably the captured the material that come from the Moon. And because I mean, coming from the Moon, I'm sorry, coming from the Sun. Remember, the solar rays are mainly hydrogen particles and also electrons. So now you have them on the Moon, and you have them also everywhere else in the solar system. And it has actually a little bit of water. We know that now, mainly in the poles, most likely in the South Pole and probably also in the North Pole, and also maybe in the shadows too, in the form of ice, of course, not in the form of liquid, because the Moon is super cold compared to the Earth in here. Of course, when it's daytime, it's super hot. That's why you don't have a moon. You don't have water, liquid water on the surface of the Moon. In addition to the fact that it has almost no atmospheric pressure because it has no atmosphere. In terms of rotation, the Moon now goes about 27.3 days around the Earth once, and in the same time completes a 1 day on its surface. So basically, the day on the Moon is 4 weeks. And that actually presents a challenge for Moon missions, because if you're going to go there and you start collecting light for solar energy from the sun, you basically have 2 weeks worth of sun, depending on your location though. If you are in the northern hemisphere and it's winter, you don't have much of sun because of the angle with which the sun is hitting. But then you have the morning, which takes almost 3-4 days, and then the evening, which is not. So basically, you have about a week worth of good sun from the sun when you are in the sun in a month. You really don't have a lot, so you need to really store that energy, okay? And you need to be in a place that protects you from the solar rays, because again, there is no atmosphere. There are so many challenges for the, especially if you're going to have a manned mission to the Moon, and where you're going to be staying there for a long time. You have to worry about the energy. You have to worry about the water. So you remember that ice I mentioned in the north. So you really have to be close from that to extract it from the ice, extract the water and the resources from there. Thank you.